We know that distance traveled is the area under the curve. So for first 4 seconds, the area will be this area. How does one calculate that area? Just calculate how many boxes are there, small boxes.
Approximately 13.
Approximately 13 boxes.
So 10 boxes.
There are many more. I am putting dot for full or nearly full boxes.
57 boxes.
Let's see.
Sixty-one boxes.
Can you just tell me the dots? How many dots are there?
So 58 dots. 58 dots are there.
Can anybody else
58
confirm?
box. 58 box.
Okay. If anybody does not agree with 58 dots, I'm asking dots right now. If anybody does not agree with 58 dots, let me know. So you agree with 58 dots. Boxes are more than 58. Let's combine these two. Together, let's count these as one more. Let's combine this two also. One more. Then these two also. One more. These two also. One more. And regarding this one, let me merge that one with this dot, which we have already calculated. So approximately 62 boxes. Approximately, of course. Now let's look into the width part. 1, 2, 3, 4, 5. Width of one box, let's say, is x. So 5x is equal to 2. X is equal to 2 by 5, which is 0.4 second width. Let's look into height now. Let's say height of one box is y. So 3y is 2. Y is 2 by 3 meter per second. Area is 62 times one box. 62 times one box. But area of one box is xy. Each box is like a rectangle. So 62 boxes will have 62 XY area, which is 62 into 0.4 second into 2 by 3 meter per second. Second will cancel out. Can you simplify this?
Sir, around 16.5.
16.5. I think that's looking fine. Any questions? Then let me know. Now that's not going to be very accurate, because after all, we have said these two are one. We can't say that with surety. It's an approximation. And that's why calculus is required for accurate calculations. There's a process called integration which can give you the perfect answer. Since we have done this part, we can now shade. That's the area. Which part of the graph represents uniform motion of the car?
So 6 seconds onwards.
6th second onwards, you're right. It's flat line. That means speed is fixed, not going to change. After 6th second, any questions? Let me know. This is the last thing to be discussed in this topic. Uniform circular motion. Consider some particle moving in this circle. It can have variable speed at different points, but let's say the speed is same. Then it will be called uniform circular motion. Otherwise, it is just any circular motion. There are many practical examples of circular motion. Somebody taking a turn, the road has the curvature, and somebody takes a turn. Think about some planet moving around some star. You take a stone, tie it to a string, and then you rotate it in a horizontal plane. Many examples. Now, first thing is that it is not a one-dimensional motion. Your scope till now was about one-dimensional motion, one direction only. Nature has got many dimensions, and for space we talk about three. One line is one dimension, two dimensions make a plane, like the screen is a plane. It's about two dimensions. Your screen has got two dimensions. But there is no depth. If you look at the screen, where is the depth? It's just the surface. So there's a third dimension of depth. And because we have got two eyes, that we are able to appreciate depth. We are able to have that three-dimensional perspective because of two eyes. There's a reason for two eyes and two ears. Now, of course, one talks about fourth dimension as time also. And in modern perspective, it is being thought that there could be many more dimensions that we are not aware of. But anyway, for current discussion, we need two dimensions. It's a plane. Two dimensions make a plane. So don't ever try to apply the results that we have discussed for one-dimensional motion here in case of circular motion. Never. If it is uniform circular motion, the job is really easy because speed is same. And if speed is same, speed is distance upon time. If speed is same, it is distance upon time, whether it's a motion in one dimension, or it's a motion in a plane, or it's a motion in space. Speed is distance upon time, if speed is same. So in uniform circular motion, speed is same. But then, the interesting point is about the velocity. Before I talk about velocity, let me just write speed equal to distance 2 pi r divided by time. Capital T is the time taken for one revolution. Say starting from here, starting means you press the stopwatch, particle is moving, comes back here. That time is capital T. So that is speed. Now talking about velocity. Circle can be thought of as a polygon. How can you think of circle as a polygon? Look at it this way. Triangle, square, pentagon, hexagon. Out of these, you will find that hexagon comes closest to becoming a circle. Likewise, if I don't stop at 6, hexagon has 6 sides, but I keep on going 7 sides, 8 sides, 9 sides, 1,000 sides, then one point will come where it will be difficult to differentiate between the polygon and the circle. So circle can be thought of as a polygon with infinite sides. Now, why is that important? So that you can visualize the change in direction. Imagine somebody traveling in hexagon, some particle traveling in hexagon, along the borderline of hexagon. At this point it is traveling here, at this point it's traveling here. It is changing direction, isn't it? It is changing direction. Whenever it reaches a vertex, it changes direction. Now just imagine if I make these sides infinite. If I make the sides infinite, then it is changing direction every instant. Every instant. There is vortex everywhere. 6 vertices in hexagon, infinite vertices in a big big number of sides, huge number of sides polygon. Infinite vertices. If there are infinite sides, there are infinite vertices. Change in direction takes place at every vertex. So every instant it's changing direction. So circular motion is always about change of velocity. Even if it is uniform circular motion where speed does not change, velocity has to change because velocity is a vector. It has got a direction also. So just by saying that the magnitude of velocity does not change does not mean that velocity does not change. If any one of the two things change, the magnitude or the direction, if any one of the two things change, then velocity changes. So direction changes, whether it is uniform circular motion or non-uniform circular motion. Direction changes every now and then. If there is a change in velocity, there has to be some acceleration present. Otherwise you cannot change velocity. Without acceleration you cannot change velocity. Acceleration is the rate of change of velocity. So one should not relate acceleration as something which changes the speed always. Acceleration may not change speed always. In uniform circular motion, speed is same. But acceleration is changing the direction. So if I say that there is some satellite going around the earth in circular path. You know there are many satellites these days, man-made satellites that go round and round and round and round the earth. So if there is a satellite which is traveling with the same speed and in a circle around earth, then there must be a way to provide it acceleration. Without acceleration, it can't work like that. So it is getting some acceleration, and that's why it is able to move round and round and round. So when we discuss some other topics involving force and gravitation, then you will understand who provides the acceleration. For any circular motion, acceleration is required, whether it is uniform or non-uniform circular motion. Now, if the particle is here and is traveling like this, what is the direction of its velocity? Direction of velocity is along the tangent. How do you get the tangent? You join the 2 points. Tangent is perpendicular to the radius. When you join the 2 points, you will get the radius. And tangent is always perpendicular to the radius in case of circle. That's how you find the direction of velocity. If it reaches here, then its velocity will change. Now it will be going in this direction. When you are inside a car or inside any vehicle and that vehicle is taking a turn, you will generally feel something. You will feel as if you were thrown to the other side. If it is too fast, you will certainly feel that. If a cyclist tries to take turn too rapidly, the cyclist is bound to fall to the opposite side. Somebody is traveling like this, let's say anti-clockwise, too fast. Then that person is going to fall to the right side, opposite direction to the center. So you will see that in racing, if it's a motorcycle race or a cycle race, then the motorcyclist would bend his leg. Cyclist would bend his leg. Or you will see that the track where racing is taking place is not flat. It is intentionally made inclined so that high speed is possible without falling. All these things that you find in nature, in life, they all have to do with this type of acceleration. Somebody has to provide acceleration. Otherwise, velocity will refuse to change. Now, one interesting question is that, suppose you have got a thread. Suppose you got a thread. This is a thread. This is a stone. And it is rotating anti-clockwise. And there is circular motion. And the thread is cut somehow or is broken somehow. In which direction will the stone go?
Sir, along the tangent.
Along the tangent, along velocity, along its velocity. And its velocity is along the tangent, so stone will go along the tangent. So sometimes there is a misconception that stone will go in this direction. That's not going to happen. Where it was going, it will go in the same direction. It was going in this direction, it will continue to go initially in that direction, initially, till gravity plays its part and changes its direction. In case of uniform circular motion, acceleration is given by v square by r. It is also called centripetal acceleration. Why centripetal? Because it is towards the center. You don't have to worry at this stage about centripetal acceleration too much. Can you give an example? If it is possible at all. If it is possible at all, then can you give an example?
Sir, if an object travels in a circle or it went some way and returned where it started, then the displacement towards is 0. So the velocity will be 0.
How can the velocity be 0? Can you explain that?
Sorry, sir.
The object doesn't travel at all, it has constant. That is, the acceleration is 0, so
This question is not related to circular motion, by the way. What happens when you throw a ball up? What happens at the highest point? Doesn't it stop? At the highest point? But then it comes down. That's because under the gravity, everybody has got same acceleration near the surface of the earth. Everybody, all particles near the surface of the earth have got the same acceleration. Free falling particles, of course, free falling particles. So if you throw a particle up, it stops momentarily, but doesn't stay in the air, it falls down. That is because Earth is accelerating it. And the acceleration provided is 9.8 meter per second square, it is fixed. Whether the particle is going up or is coming down, that number remains fixed. Can you give an example if it is possible at all?
Sir, if an object is tied to a string and we push it, it doesn't move straight, but it curves. In this case, the acceleration is in the perpendicular direction, but it goes in another direction.
Example is circular motion. Say a particle is here, uniform circular motion. Example is uniform circular motion. Say a particle is here going here. Velocity is here. It's traveling in round and round motion. Acceleration is called centripetal because it is towards the center. So the acceleration is in this direction, which is towards the center. And we know that in circle, radius and tangent make 90 degrees with each other. That's always the rule with circle, that tangent and radius make 90 degrees with each other. So it is very much possible, and the example is uniform circular motion. Any questions? Let me know. Assume uniform circular motion. Assume uniform circular motion. This is your assignment question. We stop now.